you've got to love science, haven't you? And you've got to love what you can do with everyday things. Now, we're going to make a speaker, and we're going to make a speaker by drawing it onto a piece of paper with a pencil. Now, this is a soft lead pencil. It's actually a 6B. And the shape that you need to draw, and I'm drawing at the edge of the paper so I can connect to it. There you go. That's it. That's our speaker. That's what it looks like. Now, you're going to connect here and here. It actually doesn't make a lot of sound, so it's going to be a bit difficult to hear it, and we're going to turn that into an earbud. But let me give you a close-up of how it actually operates. We're going to connect it to the amplifier, but we're going to connect it to the amplifier through this. This is a high-voltage module sold on eBay for about £2 to £3. It takes a 3-volt input, which is these two wires here, the red and the white. Red's positive, incidentally. And it outputs the high voltage on these two white wires. Now, it outputs about 5 to 7 kilovolts, something like that. So it's a high voltage. You don't want to be touching this. Now, these are sold as igniters, that kind of thing, and they're incredibly cheap, and they are a potted circuit in there, and we'll go into the circuit in there in a different video, but you can not only buy them that size, you can buy them that size, about £3. This will output about 20,000 volts from a 3-volt input. So that kind of thing, I mean, you know, they're sold as igniters, but I've seen people making stun guns out of these, and it's just incredibly easy. I mean, you get two 1.5 volt AA batteries and pop a switch in there. Connect the positive of your batteries there, you switch, and then you switch to there. Press that switch, you'll feed that with about 3 volts. Set that about that far apart, say, and set about 3-4 centimeters. You have yourself a stun gun. You touch somebody on the arm with that, that's going to hurt. Touch somebody in the base of the spine, they're going to fall down and wee themselves. So you can actually really stupidly easily make a stun gun out of that. But we're going to use this one as a driver for our earbud, this one here. And to connect the amplifier, positive, which is central pin on that one, the ground, which is the outside pin on that one, turn on your music, and you will create a high voltage arc between those two, which will be in time with the music that's been fed into it. Anyway, let's connect that up and have a close-up. Okay, wasn't that awesome? You could see the actual paper moving and you could just hear the sound. So it's quite quiet, but it works by vibrating that piece of paper. And of course, to listen to it, what we need to do is create some kind of resonant chamber around it, just like an earbud. And to do that, we're going to use a bit of plastic water pipe, because remember it's 7 kilovolts. Bit of plastic water pipe, cut a section of it off, there we go. And we need something that we can rest our head against. And we've got this wheel cut from, you guessed it, builder's board. We glue that on there, and then we put this right there, and we have our resonant speaker. So we put that there. Now, of course, we need to insert it into our ear, or get it close to our ear. And a good thing is the bottom of a pen. So we take the bottom of a pen, and we stick that in there. We have our earphone. Now, that's going to be a bit horrible, so I've pulled a little plastic bit off of an earbud. We pop that on there. That's it. We have made our earbud. Now, I have made one of these already and tested it, of course, and here is the one that I made earlier. So you can see it's the bit of pipe, plastic disc, pen, earbud, and there is our speaker right there, which is just this. And we're going to listen to that. Okay, that's it set up. Let's start our infamous music, which is getting to be a bit of an earworm actually, because we've been playing it so much recently. And let's have a listen. That's actually quite good. Hey Luke, come have a listen.
So I just stick my ear in it, yeah?
Just stick your ear over there, mate. Be careful not to touch these two, but this sort of this big plastics here.
Okay.
You don't need to press it, just hold it.
Oh yeah!
Isn't that cool? I mean, the reproduction's actually quite good.
Yeah, I'll tell you what, that is actually relatively clear. That's good.
Yeah. So there you go, guys.
Works.
How to make a earbud speaker just by drawing it on a bit of paper. I thought that was really quite impressive, to be honest, and very cool. So if you want to actually hear it beyond what we did on the sample, knock yourself out. I mean, you're talking about a piece of paper and one of these things. So we drew this on a bit of paper and turned it into an earbud, which actually worked to reproduce the music quite well using a high voltage step-up transformer circuit for a couple of quid. Now there's lots of interesting things about that. I mean, one of the things is, what is this? Well, this is an asymmetric capacitor. And asymmetric capacitors obviously have a lot of interesting features about them, and one is the ability to produce thrust, and we saw that in the video, and we saw the paper waggling around. Now that hasn't escaped everybody, of course, because it's based on the Biefeld-Brown effect. And NASA did some research into high voltage thrust capacitors based on asymmetric capacitors, and here's the patent. And of course quite a few people have done replications of that, and here's a quick snapshot of somebody's replication. And so the ability of an asymmetric capacitor to create thrust is well known, well understood, and has quite a lot of research on it. Now the other aspect of this is these things. These things are quite incredible, actually. There's been a couple of people who've pulled these apart, and Big Clive talks about them, but he didn't pull it apart, he just talked about it a bit. And then a couple of people have sawn these up, broken it up, and reverse engineered the circuit. And the circuit's really quite simple. It's initially a tickler circuit, the same kind of circuit you'd find in a Joule thief or in a flash camera charge circuit, where you have a transformer where the secondary winding is the output, the primary winding is tapped to defeat two coils. So you input on one coil, and of course what that does induce a current in the second coil, which you use to drive a transistor, turning the whole thing off, and so you get a frequency. And that frequency is dependent on the balance of the capacitance and the induction of the particular coil side, which you can change by adding a capacitor. You can't zero down on it, of course, because a simple arrangement like that, the load affects the frequency of a transformer like that as well. But basically, it's a tickler circuit and a high frequency on the input from a DC, because that on-off then transform it to high voltage, around about 1000 volts or so on the secondary side. That 1000 volts is usually put through something like a Marx generator or something like that, where it can step the voltage up even more to the voltage requirements of these things. And this one's, it's about 5 kilovolts. This one's about 20 kilovolts or so. If you were to run that by leaving those open like that, of course you're going to damage the circuit, so they need to be in close proximity, or you can just wire them to a couple of pins. So in a stun gun, what happens is you have two pins. The pins are usually just a loop of metal like that, and there's another one either side. These ones are the ones that you stick into people. These ones are actually safety pins, so they're usually about 1.5 centimeters apart. So if this output goes above 15 kilovolts, of course they arc, and you get that pretty crackling that you see on stun guns, and it also limits it. But they will preferentially go through the pins that you stick into somebody, because our ability to resist that is much lower. So we have breakdown voltage of skin and clothes is lower than 15,000 kilovolts. So if you stick it into somebody, then of course it's going to go through that, and you get massive nerve stimulation in the area, and it's pretty painful. So if you were making a stun gun, you need that safety feature to stop you frying the electronics of these. Because although these are 2 or 3 pounds, of course people tend to
put the battery in and then have a wonder about it and then bring them closer till they arc, but of course there's a long time between there, and you can fry the electronics in there quite easily actually with that. But if you put it onto that little safety feature, then you're going to be able to do that relatively easily. Now, it can cope with it for a little bit of time, which is why we ran this directly from the amplifier to run this, because that amount of time really, there's plenty for something like that. But if we wanted to do something more permanent with this, and you were, say, building an electrostatic speaker, then having that crackly safety feature would probably be a really good idea, just to preserve the electronics in here, even though, as I say, this is about £2 or £3 and stunningly easy to use. All you do is connect your amplifier to those two sides. That's your positive, that's your negative, and then obviously that would go to your electrostatic speaker. Now, we did this with the asymmetric capacitor because it's a quite a cute way of introducing asymmetric capacitance and that idea of surface thrust. So that was kind of interesting. But electrostatic speakers obviously are already built where you get the two electrostatic surfaces, and you could certainly build an electrostatic speaker from something like that. And I think it would be kind of cool to look into asymmetric capacitors and thrust with something like that, which is why we built that. So it's kind of cute, and it works, which is obviously a benefit that it works. So it's kind of cute and a benefit that it works, and it would make pretty good earbuds. And if you think about it, that's actually the active component. So how much would that cost, and how much material would that use? I mean, next to nothing if you think about it. So we could get rid of the magnets already in there. If you take an earbud apart, you will find a small neodymium magnet and a small voice coil. We can get rid of the coil and the magnet and paint it on a little bit of paper. If we put one of those in the output jack of the any device that needs an output jack, that would literally be your earbud. And I find that kind of impressive. If you could really get people to do that, then all those earbuds, and earbuds don't last that long, all those earbuds would be a matter of a piece of paper. Anyway, I thought I'd go into a bit more of the background, which I think is kind of fascinating in itself, and obviously where this stuff could lead to, because I mean, science is like that.
So, hope you enjoyed the video. Thank you very much for watching, and please remember to like and subscribe.